Welcome to Revolution Against Evolution. I'm your host, Doug Sharp.
I'm your co-host, Rich Gear here, and we're going to be talking about moons tonight, Doug, aren't we? Is that
Planetary Moons.
Planetary Moons.
We have, I've been editing a video for Jerry Bergman for his classroom. Actually, he has two videos called What You're Not Told About Astronomy.
okay?
And the fellow who did these videos, his name is Spike Pissaris.
Spike Pissaris?
Pissaris. I guess he's a Greek guy. But anyway, he has done an excellent job with these videos, and a lot of the information that we're going to talk about in our show tonight will come from these videos.
So Jerry branching out. I've not seen him do much on astronomy before, you know?
Yeah, I guess his astronomy class is going to be one of the best attended at the community college where he teaches.
Really? Okay. All right.
So he was wanted me to edit it so that we take all the preachy stuff out, because
yeah.
Spike's video has it's really a gospel
It's going to have the
message.
gospel message in. Okay. Yeah.
And so I had to go in and do a lot of that. So anyway, what I wanted to talk to you about tonight is are the moons in our solar system, which I didn't realize there were so many of them when I were investigating this with Spike's video, and a lot of them really have some very interesting characteristics and,
Yeah,
and things.
I was talking to you. We were talking earlier, and some of our technicians here. I'm still living in the '60s, where Jupiter had 8, 10 moons, or I can't remember what it was when I was growing up. But now, because of all these Voyagers and what'd you say, the Cassini probes and Hubble telescopes and all the stuff that's going on, they found, how many moons do we have, Doug?
There's 181 moons in the solar system that we know of right now, and
I was reading some of the stuff in Saturn. They're not sure because they're in the ring, and
Right,
they may
yeah.
be too small to be really moons. They might be. You don't know. So,
But anyway, the moons that have any significance that have been discovered so far, Jupiter has 67 moons, and Saturn has 62.
52. Yeah. Was it Neptune or Uranus has 27? 27 moons or something?
27 moons,
Yeah.
and 13 and Neptune that we know of.
As far as we know, Venus and Mercury still have no moons,
Right.
and that's interesting to me. Okay.
And let's start with the Earth's moon for just to stay close to home. For
Sure, why not?
a little
Yep.
bit. Well, some of the things of interest to creationists about the Earth's moon is its distance from the Earth and in comparison to the distance of the Earth to the Sun, and it's a situation where a total eclipse of the moon is
Yeah.
possible, and it's the only place in the solar system or in the known universe where you can view a total eclipse of the sun, because of the
ratio
the
and
ratio
where it's at. Yeah.
because it's it covers the sun, and it actually covers the Earth's shadow,
Right.
covers the moon just completely, and so the sizes of the three objects in this relative view in the sky are all the same.
Yeah, that almost, that does not seem accidental. We can't prove that it's purposeful, but man, it's like boom, boom. The size and the ratios to get to that perfect thing.
The scripture talks about the sun and moon being signs in the heavens.
That is true, yeah.
And I think this is one of the biggest signs that God has put there to tell us that this is something that He put there in the sky for this own purpose. And
Right.
And the other thing that's interesting about the moon, our moon, is that the same side of the moon faces us all the time. And it is actually essential for life on Earth, because it really controls the tides and the oceans, in the oceans.
How is that essential for life on Earth, by controlling the tides? What does that do? Do you know?
Well, it keeps the
The ebb and
motion, ebb and flow of the ocean. It just keeps it always in motion.
keeps moving, and that's good for life on the planet.
Yeah, it affects the weather, and it affects a lot
Well, we
of
know that, yeah.
a lot of other things that we know on Earth. So the moon actually has a beneficial effect on the Earth, and some people in the ancient times used to think that you were loony because
because the influence of the tides would cause, lunacy comes from that same, lunacy and your Looney Tunes,
Yeah, and it's like in the old movie, you were over the moon because.
Well. So, anyway, so that's the Earth's moon. Are there any other things neat about the Earth's moon? I mean, we know in times past we had all kinds of things about creationary predictions and evolutionary predictions and all that kind of stuff, and some of those have been thrown out. But still, it's kind of interesting to see, because it's one of the largest, isn't it one of the largest moons for a rocky planet?
It is.
Yeah.
I think it is the largest moon.
Because I know Mars is a rocky planet. It has two moons, but Phoebus and Deimos, I think Phobos and Deimos. Fear and terror, fear and dread, I guess.
Yeah. And the interesting thing about those two moons, as well as some of the moons surrounding the other planets, is that they travel around the planet in retrograde, which is the opposite way that the evolutionists expect. Now, if you
mean the moon around the Earth revolves in retrograde?
No, the moon around the Mars.
Mars is retrograde. The moon is prograde or
prograde is what the moon does, and most of the moons travel around the planet in prograde.
Okay.
And
but Mars does not.
Mars does not.
Interesting.
Both
Okay,
moons
I didn't know that.
Are retrograde, and the planetary nebular hypothesis is what the evolutionists have as their model for how the solar system formed, where you have all this gas that comes together. You have all these little planetesimals that
when they coalesce into a moon,
coalesce into the little lumps start to clump together and make big lumps, and and you have all this problem with them clashing together, and but in order to have something that's big enough to form gravity, you don't have these things clumping together.
right?
You have to, and if you're considering all the distances that are involved in this case, you really can't imagine how these planets would have formed. As a matter of fact, the gas giant planets of Jupiter, Saturn, Uranus, and Neptune, the dirty little secret of the solar system physicists is that they shouldn't exist.
What, the gas giants?
Gas giants.
Now, why shouldn't they exist?
Well, because they would have been drawn into the sun during its formation. It would have.
Oh, yeah, I never thought of that. Yeah. Well, it's interesting, Doug. Are all the moons made out of ice or rock? There's no gas moons, right?
I think you're correct on that. They're all icy and rocky, and the biggest surprises was the Galilean moons, the 4 Galilean moons of Ganymede, Callisto, Europa, and Io.
Okay.
And
Titan wasn't one of those?
Titan's Saturn.
Okay. Oh, you mean around Jupiter? Okay. All right. So what was surprising about those?
Well, they're all different. Ganymede
Yeah.
has all these different faults, and if you look at it, it looks like it was painted over by with paintbrush,
Yeah.
because it has all these lines and faults, and it looks like some giant hand went across it and started making all these marks across it. Now, Callisto is different in that it's the most heavily cratered object in the solar system. It's
Wow.
just got craters on top of craters on top of craters. And
Okay.
so, but the Ganymedes is so much different from that than the Callisto. And then you have Europa, and there's hardly any craters at all. And they figure that it's an icy.
Ganymede got hosed and Europa got escaped, huh?
Yeah,
Or
I think
escaped
so.
the dam. Okay.
And then you have.
Is Europa, you said icy?
They were considering, well, there might be life on Europa.
Oh yeah, I know.
Because
Yeah.
there appears to be ice or water or
Okay.
something like that. And so
Right.
underneath the ice, they think there's water, there's an ocean, and maybe it's warm underneath. Now, there's the problem, is that if there's still a residual of warmth, it can't be that old.
Yeah, I know.
And
Well, the other things too is we've talked about this a number of times. I think even last week we might have talked about the idea of water. Through an evolution, it's like magic. You got water, you got life. I go, the old Porgy and Bess tune, it ain't necessarily so.
that's right, yeah.
That's exactly right. Water prevents life from ever happening.
Well,
Yeah, without it you can't have life.
Let me explain that,
Yeah.
because that's not entirely true. You
Well-
have to have water to have life.
Correct.
But water, in the original formation of proteins,
Yeah.
that's where it sort of works against the idea of life coming
That's what I'm
about.
saying. That's what I'm getting at. Yeah. Yeah.
Well, we have to explain that because
No,
not
I understand that, but I'm just saying, yeah, well, you need water. That's what I just said. I said, without water, you can't have life. But water, at its fundamental levels, will stop the bindings, and
Yeah,
it's
you
like a
need to
corrosion.
have some sort of protein assembling mechanism in order to
make
have
it
this
work.
stuff put together. You actually need proteins to make proteins, which is interesting.
Yeah, yeah. So we've talked about 3 of the 4 moons. You've got one. You have lots of craters. That's Ganymede, right? One that looks like a paintbrush artist. That's
Ganymede.
that's Ganymede. Okay.
And the Callisto is the heavily cratered one.
The
The
Callisto's
one
the one.
without craters
Craters.
was mostly an icy. The surface is Europa.
Europa,
And
and
then
then what's-
Io. Io is the pizza moon.
The pizza moon.
Yeah, because if you look at it, it looks like it has so many volcanoes. It has all these dark spots that look like pepperoni pizza.
Oh, okay. All right.
And you can actually view the volcanoes spewing out all the ash.
Really?
And you can see it in the photographs that the mission that went to, I think it was the Galileo mission that went to view the.
Are they still shots or are they moving shots?
Well, I think they did both.
They did some video of it. Okay.
But
I didn't know they get that close.
most
but-
of it's NASA has all kinds of free stuff of this sort that we can borrow for our,
Your tax dollars at work. See, I like NASA, but that's one of
Yeah.
the things where I like when they
NASA. I like it when they spend millions of dollars come up with all this information that proves our theory.
It helps
right.
us out. Yeah.
But if you go through the entire litany of moons, every time we have gotten new data about the solar system, it always mystifies our evolutionist friends because there's really no way that their planetary nebula hypothesis works because the rotation of it sort of goes against the
Yeah, backwards and forwards motion.
Right.
Yeah, why would that happen that way? I don't know. Yeah. And they're not elongated. We
Right.
talked about that before. That kind of mitigates against the motion or the capture theory in a lot of respects, right? Didn't
Right.
you say that? Because the orbits are fairly evenly circular. We're not saying it's exactly circular, but pretty. They're not really elongated. Like if it would have captured something, it would have had kind of strong, elongated patterns.
Now, what happens in a lot of these planetary theories of moon formation is that they invoke catastrophism to come up with explanations why it isn't the way that they expect it to be. And so, like in the case of Mercury, where Mercury has a really dense core, and they weren't expecting that. They didn't expect Mercury to have a magnetic field. It does have one. And of course, Russ Humphreys did his seminal paper on how planetary magnetic fields really fit the prediction of a young solar system model. And a lot of the moons of Jupiter were measured for magnetic fields, and some of them have magnetic fields.
Yeah, they would probably be, some of those are big enough, they would be small planets or even dwarf planets on their own, except that they're orbiting another planet. Isn't that the way it is?
Right.
I mean, that's a question you might want to, because I don't really understand fully what the definition of a moon is, or even a planet as far as that goes. I mean, is there a size that needs to have happen? Is there an orbital pattern that needs to have happen, or is there a combination of factors?
I think it's what we decide it's going to be.
Yeah, kind of. That's what I'm wondering, because
sort of like with the recent New Horizons visit to Pluto, we have another example of what was once a planet now being demoted to a planetesimal. Or
now it's a dwarf planet, so it's kind of getting built back
yeah.
up again. It got knocked out to like basically I don't know, an asteroid, but it was basically a planetesimal.
Well, if it's
a dwarf planet.
If something has 7 moons, it's got to be a planet.
That's what I'm thinking. That's, to me.
Yeah, it's interesting. Pluto's moon Charon is just a little bit smaller than Pluto itself, and so they sort of orbit around each other.
Wow.
Orbit around a certain.
Could that possibly be a dual planet thing or something? Or, I mean, they consider one a moon and one the planet. Is Pluto rotating around the other, the Charon, or is it staying?
Well, they're both orbiting around each other.
They're going like this?
Yeah, they're orbiting around a common focus of a ellipse.
So why isn't Charon and Pluto both considered dwarf planets?
Well, I guess
I just had to put it out there. I don't know how this all works. It's fascinating because I mean, astronomy is very interesting, but it seems like it's almost more interesting what you don't know as opposed to what you do know.
Right. Each time and the geology on these planets all are so fascinating and different. One of the moons of Uranus, Miranda, is so fascinating that they explain it not by one comet impact, but five different planetesimal impacts.
Oh, okay.
So they figured that it was so whacked up that.
Really? Why do they figure it? I mean, does it look bad, real badly damaged?
Yeah.
How they cratered?
It looks like there's it's sort of like Ganymede in that you have a whole section of it that's straight. There's like a check mark on it.
Okay.
And there's a deep canyon. It's like 7 miles deep. And this is a moon that's like 300 miles in diameter, so it's kind of a small moon.
Kind of a dinky, okay.
But it's so whacked up that they were wondering, well, how did it get that way? They had to explain it. Well, we not only had had one catastrophe, we had 5 of them.
Okay. See, catastrophe is good for every place in the solar system except Earth.
Right. Yeah.
Okay, just checking on that. Okay.
And so apparently we're relatively protected by God,
Well, you think about that. I mean, really, the Earth, we've had a few impact craters and stuff
Right.
over the millennia, but relatively unscarred.
Yeah, it's interesting that
Has the moon, our moon itself, run some interference for us? You think maybe?
it might, yeah,
Yeah.
but it's interesting that our moon is heavily cratered.
That's what I'm saying.
And even on the backside of the moon, there's a pretty large impact crater. But we're not immune from impacts because
No.
like in Quebec, there's like half a dozen or more different impact craters, like the Manicouagan Reservoir is one, they call it the Eye of Quebec, and then there's two impact craters next to each other.
Would have been those, Doug, would have those been like post-flood, or, you think? Or-
Well, we
Do we
can't
have-
really.
I mean, I just wonder if
That's
there's
in
any
the
speculations on
Canadian
that.
Shield, so that might be in basement rocks right there.
So could it have been a factor in the flood tidal thing?
Possibly, yeah.
That's what I was getting at, whether, sometimes
There's a lot of people who actually postulate crater, meteorite impacts as being the cause of Noah's flood.
Yep.
So, a couple of the interesting moons that came about as a part of the Cassini probe was that of Saturn.
Cassini probe went out when? When was it? When was it
Well,
started?
that was a few years ago.
It just, fairly recently.
Yeah.
Anyway.
And the biggest one of interest is Enceladus, or Enceladus, I guess is how you pronounce
Okay.
it.
I never heard of it, so yeah.
And what when they were approaching it, they found that there's actually coming out of the south pole of this moon was a huge geyser. It's like
Really?
it's spitting out.
What was that?
It's amazing.
What's it
how-
spitting out?
Uh,
Ammonia,
it's,
water?
It's probably but whatever it is, it's actually spray painting neighboring moons.
That is one huge geyser.
It is.
Wow.
And it's really amazing. It also speaks of its youth because there has to be all kinds of energy coming from
Yeah,
it
thermal
to be able to do that. In fact, a lot of the planets and the things of like Uranus, Neptune, and Titan is another one. I'll talk about that.
Yeah, let's talk, okay.
But they give off more energy than they take in from the sun, because there's
Really?
there's actually a lot of heat that's generated from residue from its original creation, and so each of these things, the magnetic fields, all which have been measured by the satellites that have gone out there, and Dr. Humphreys predicted that what they would probably measure as the intensity of the magnetic field based upon his theory.
Right.
And his predictions were right on, whereas the evolutionists predicted way low because
Right.
they were preconceived of
What-
long ages.
So Doug, what ad hoc explanation have they come up for that then? Have you heard?
Dynamo theory.
Oh, yes, okay. Same thing they use for the Earth.
But the dynamo theory doesn't work, especially in it wouldn't work for
It's
Saturn.
going in one direction, it's not going down and then back up. And
Right.
Isn't that what the dynamo is? It winds down, then winds back
Well,
up?
they figure there's something inside of the planet that is doing the moving around.
And there's no evidence for that, is what
And
you're
there's
saying.
no evidence for it, and what they were looking for as the cause for it wasn't there. And so they're shaking their heads baffled, trying to figure out, well, how can we come up with a theory of the origin of the solar system?
Well, Doug, go ahead, I'm
They're
sorry.
not able to come up with it.
So, we got a couple of minutes left, Doug. Did we miss Titan? Did we talk about the Titan moon?
Titan, has methane in the atmosphere, and they can't figure out why it would have methane, because
Too many cows on the planet?
Well, it would have dissipated long ago if there was, and they figured that because of what they figured the age was, there would be oceans of methane on the surface. Well, they actually sent a probe into Titan,
Right.
and the surface was sort of like a desert.
Really?
And
So the atmosphere's methane, what you're saying?
Methane,
And then
they
you go
figured-
below the atmosphere, it's,
If they figured that the methane should have gone to ethane, you had oceans of ethane,
right.
but it didn't. That wasn't the way it was. Now there were some little pools down there,
Yeah.
and they can't. They weren't able to detect what they were, but even assuming that these little pools were ethane, it doesn't account for the fact that they, for the amount of ethane that it has in the
Sure.
atmosphere. So there's also all this
Man.
stuff that, and Spike's video only covers just a little bit of it, but there's even asteroids that have moons.
Yeah, that, because you mentioned that earlier, what is that all about? I mean, we gotta wrap it up, but, oh man, I guess maybe we'll just leave it with that unless you got a thought.
Well,
too
there's
com-
too many things to try for the evolutionists to explain.
Yeah, there are.
And so I hope you guys give up. We'll see you next time on Revolution Against Evolution.